So what is the Compton effect, first of all? And why do we have to know what the Compton effect is? So the basis of X-ray imaging is that the X-rays go through the patient's body and they're attenuated or scattered by various mechanisms. And as a result, some parts of the screen are dark and some parts are bright. And we have to understand how why some parts are bright, some parts are dark. And there's a number of phenomena which are involved in that. And the Compton effect is one of those phenomena. So that's why we study the Compton effect. The Compton effect depends on a number of factors. So it depends on the type of material which the radiation is passing through. So the different types of tissues in the body. It also depends on the energy of the photon which is used to form the image. So if you're looking at diagnostic radiology, the Compton effect is relatively constant over the photon energy range we're looking at, which means that the energy of the photons is not a major factor. So we won't be discussing that in our discussion right now. So we'll be looking at Compton effect for diagnostic radiology, and we won't be taking into account how the effect changes based on photon energy. All right, so what happens in the Compton effect? Essentially, there's electrons at rest in the human body. They're free electrons, which just means they're not bound to anything. And what happens is a photon, which is one of the particles of the X-ray radiation, comes near the free electron. And then there's something which is like what happens when you're playing billiards on a billiards table. The photon, you can imagine it knocking into the electron. The photon goes in one direction and the electron goes in the other. So the term free electron is slightly important here. If one of the pool balls is tied down to the table, it won't be able to move freely when the cue ball strikes it. Similar here, the photon is only able to do this when the electron is a free electron, when it's not bound to an atom. So after the photon hits the electron moves in one direction and the photon moves in a different direction to how it was originally moving. So how does the energy come into play here? Essentially, there's a certain energy which ties the electron to the atom or ties the electron to its position. And it's only if the incident photon has enough energy to overcome this that the electron is able to move. So at this stage, it's important to know some of the basic formulas about energy. So you can see the formulas here. E is equal to hf, E is equal to hc by lambda. Here, E is the energy of the photon. We'll just look at the first equation. E is the energy of the photon, H is just a constant or a number, and F is the frequency. How is this important? We just need to remember that the greater the frequency of the radiation, the greater the energy. So you can see there's a graph there. So if you just focus on the red line, you can see that as the photon energy is increasing, the amount of the Compton effect is also increasing. So what does this mean? We're talking about like millions and billions of photons and electrons here. So we're talking about a large number of type scattering that happens. So if the photon energy is higher, there'll be more of these interactions happening. And if the photon energy is lower, there'll be fewer of these interactions happening. So you can think of this as, think of the electrons as a whole bunch of dominoes which are set up on a floor, and you're throwing a ball, or you're throwing multiple little balls into the floor and seeing how many get knocked over. So if the balls all have pretty high energy, then that's when much more of these dominoes get knocked over. So that's the discussion about photons here. So the photons can scatter in all directions. The electrons scatter in a certain way, and energy is conserved during the interaction. This means that the photons coming in with a certain amount of energy, the electron has a certain amount of energy in the beginning, and if you add those two up and it gives you a number like say 100, even after the Compton scattering takes place, the amount of energy you have at the end is still the same number. And yeah. All right, so a really important part of Compton scattering is that the energy of the photon changes during the scattering. So the photons coming in with a certain energy in a certain direction. After the Compton effect happens, the photon is traveling in a different direction with a different energy. And from all the experiments that scientists have done, what they've discovered is that the new energy that the photon has depends on the angle by which the photon is scattered. So there's a few examples of different types of scattering here, but what's really important for us to know is that the greater the angle of scattering, the more is the change in energy of the photon. So as the scatter angle increases, the photon energy decreases, the scattered photon energy decreases, or the scattered photon has lost more energy. So let's look at an example. In this example, the photon has almost been sent back the exact way it came. Theta is around 180 degrees. So here the photon has lost a lot of energy. It's very soft. And the electron has gained all that energy instead. And over here, you can see that the photon's hardly changed its direction at all. The photon still has most of its energy. We say it's a hard photon and has a lot of energy. The electron has very little. So that's a graph of how the electron and photon energies vary according to the angle of scattering. And we can just take a look at how these quantities relate to each other. So the greater the incoming photon energy, the scatter angle decreases, the scattered photon energy increases, and the penetration of the scattered photon increases as well. And when we're trying to understand how the scattered photon penetrates, you are thinking about the hardness of the photon. We know that the harder a photon, the more that it can travel because the attenuation coefficient changes. I am speeding through these concepts a little bit. So if you are having a hard time following, don't worry about it too much because you would, I think, take a little more time to read this when you're actually revising. So let's see how that works with some numbers. So if the incoming photon has an energy of around 30 kiloelectron volts, and the scattered photon has an energy of 25 kiloelectron volts, then the recoil electron is 5 kiloelectron volts. Whereas if you have an incoming photon with an energy of 100 kiloelectron volts, it has a lot more energy to give to the scattered photon. So now the scattered photon has an energy of 70 kiloelectron volts. That's just because there was so much more energy from the incoming photon in the beginning. And the recoil electron will take the difference in energy. So if it'll take 30 kiloelectron volts. Okay, so as the photon energy increases, the scatter angle decreases as well. So another important thing to note. And so finally, we should remember that scattered photons don't add anything useful to the final image. This is because their path through the material has been altered. So they are not usually picked up by the detector. So what scattering is doing is it's destroying some of the information that we would have gotten from the image otherwise. Okay, so once again, let's talk about the number of these type of scatterings which are happening, the probability of this effect occurring. And the probability depends on the number of free electrons. Now, the number of free electrons depends on the physical density and the electron density of the material. So probability of Compton scattering will increase as the physical density increases and the electron density increases. So you can imagine that the probability of Compton scattering is greater in bone than in air. So because the physical density of bone is greater than air. So that's a good way of thinking about it. So here's a slightly finer detail. This is, thinking about, okay, so the electron density depends on the atomic number. So does the probability of the Compton effect depend on the atomic number? And the answer to this comes from a little bit of, clinical information that we need to know, which is that most of the tissues in the body have a very similar electron density. So when we're discussing the Compton effect, yes, the Compton effect does depend on the physical density and the electron density, but in practice, the electron density of all the different tissues doesn't vary that much. So in practice, it doesn't have that much of an effect. So that was a very quick run through of the Compton effect. Now, what I would ask you to do is just, let's just try answering an MCQ in the style of the exam, just to round off everything that we've been, looking at so far. So what I will ask you to do is just open that Slido link if you've got it open. Becky, if you could send that in the chat. the Slido link once again, and I'll just switch on a timer for 1.5 minutes. So if you've got your Slido link open and you're ready to answer the question, just give me a yes, and then I'll switch on my timer. So I'll just wait for everyone to open up that link, get to the question, and then we'll try answering the question, and then we'll wrap up the webinar. So yeah, so just put a yes in the chat when you have the Slido open. I'll just wait for a few yeses, and then I'll start the timer. Okay, so I can get some yeses in the chat there. So I think there may be a problem of the Slido not being active. So if you're not able to answer questions on the poll itself, just put the answers in the Zoom chat here. Just put like TF, TTF, whatever your answer is. Okay, so I'm putting my timer on for 1.5 minutes. Okay, so that's 1.5 minutes, and let's look at the answers. And we'll also see, how do we get tripped up in the exam? So the larger the angle through which the photon is scattered, the more energy it loses. That's true. And almost everybody got that correct. So 91% marked it correct. So that's great. We discussed that. There's interaction between a photon and a free electron. Okay, so that's an easy item. So that's them like letting you get like 1 mark. So make sure you don't miss any of these type of questions. The amount of scattering that occurs depends on the electron density of the scattering material. So here's where it gets a little tricky. Here's where there may be a little ambiguity. First of all, the amount of scattering does not mean the energy change. Amount of scattering refers to the probability of scattering occurring, which we know depends on like physical density and electron density.